Morning, everyone. Let's get started. So from today onwards, we'll be discussing SQL. Spend some time on SQL and then we'll move on to Power BI. That is the plan. Okay, in our orientation session yesterday, we understood why SQL is needed because, if you want to get some data to create a report using any of these tools, you need to interact with a database, right? So that database could be any kind of a database. And in this session, we are going to use SQL Server databases. So I'll also talk about what is MySQL, Oracle, and all. And if you want to interact with the database server, you need to use a language, which is a structured query language SQL. And using that, we can extract the required amount of data, and we can use it for our reporting tools. Okay, that is what we are going to do. Right. So let's start SQL. Hold on. If any new joiner is here. Okay. Fine then. So why should we learn SQL? Yesterday also I gave you an example. You don't need to depend on IT department or any other department for that matter. So you can create your own queries. You understand the data and generate the reports as per the requirements. You don't need to explain the entire requirement to some other team to extract the data. Reduce the dependency on the IT teams, perform better than peers, and get recognized and be more employable, more skills, right? So as an analyst, you know the requirements well because you talk to the client and they explain what is that they want. And if you understand it well, directly you can write a better query there instead of explaining the entire requirement to some other team. And certain situations, it is recommended to implement these functions in SQL level itself. Because the functions are there in SQL, in report level ETL, and in the reports also. Something like Excel functions are there, Power BI DAX functions are there. But instead of implementing these functions, you can actually implement these functions, instead of implementing these functions in the reporting layer, nothing but in Power BI or, Excel or Tableau, you can implement these functions in SQL level itself. The advantage is that once you get the required data, you don't need to perform any further functions in your reporting layer, right? So you don't need to write any complex functions in for, Excel or Power BI. So you can directly get the data from SQL itself. And you will be able to easily understand the data modeling concepts in Power BI or Tableau or ClickView, right? So once you understand SQL, you can easily understand the data modeling concepts in Power BI, okay? That's the reason. So a database can be any collection of information, related information, a phone book or anything. And there are different places you can store the databases, right? On paper, you can create a database, right? In our mind is a database, right? On a computer, we can do that. Right, on a computer, yes, it is recommended to store the databases in a computer. The reason being, it has the storage devices, be it HDD or SSD or NVMe drives. So basically, they help us to store a lot of data there, right? And you can also do periodic backups to the databases. right? But yeah, database can be any related information, collection of related information, and it can be stored in any place, but recommendation is on a computer, right? Mind also a database, dangerous database, you know, forgets all important things, right? So you can't depend more on mind. The other reason being there are like so many, what do we say, transactions on day-to-day basis, right? So each and every transaction ID, how much we sold, right? Or what is the quantity, who was the customer who bought that, and remembering all that stuff is not possible, right? If you are storing it in a mind, right? So a database, as we discussed, is collection of related information, and yeah, the other definition you can say is a database is collection of data objects, right? To store and manage the data. Like we have tables, views, stored procedures, triggers, indexes, right? Different things inside a database. We focus more on the tables and views. There is a reason also. Tables and views are is a place where we can find the data. Okay. Other things also there we'll discuss. So when it comes to RDBMS, the last three are RDBMS, the relational databases. The first two can be used as database, but these are like files. Okay, not database application, just files. CSV files, a comma separated values file or Excel files. These things also contain some data, right? But not like RDBMS, right? RDBMS has tables, views, stored procedures, triggers, indexes, and so many other things, right? So Access, MS Access is RDBMS, SQL Server Database is RDBMS, Oracle DB is RDBMS, okay? So we'll talk about these things, and the files also, yeah, are there to store the data, but you cannot use them as database applications, okay? We'll see them going forward. So how Excel is different from SQL, okay? So what is SQL? Pronounced as SQL, SQL, Structured Query Language, and it is to communicate with the database, okay? It's a media through which we can store and read the data from a relational database. So most of us, we have this question also, what is SQL and SQL Server? Right, SQL and SQL Server. So to understand this concept well, let me show you a presentation. Okay, so here we go. Let us consider a restaurant example here, okay? This restaurant is a complete database environment. You can consider that, okay? Consider that way. So I'm going to show you this presentation the same way. It's SQL restaurant. So if you understand it well, then you will understand what is a server, what is a client, what is SQL, right? What is a query, what is a database object like a table, what is a view. But I'll explain this entire thing in a restaurant example so that, the terminology also looks very easy for you then, okay? So if you consider a restaurant is the entire your database environment. In the restaurant, what is it? We see like a physical building, right? Contains everything needed, organized system. So you see these things in the database. It's like a server environment, right? Stores all data and a structured storage, right? I'll show you step by step. So basically, once you enter into a restaurant, right? You see the staff there. There are different people, like there are servers available, managers available, chefs available, right? Okay. So here you can consider a restaurant server as a database server, right? Once you go in, right, you find a table and you sit, done, and you want to place some order. So would you directly go to the kitchen and place the order? No, right? So you wait for someone. Who is that? Waiter. Any other name? Yeah. Other than waiter, can we call that person?
Server.
Server. Yes, server. Someone who serves the food, right? Fine then. So you place the order, right? So you go to, let's say, you go to Hyderabad restaurant, right? And you start speaking to that server in Spanish. Yes. Will the server be able to understand that? Why? Right. You know, that server may not be okay with Spanish, right? So may or may not know that language. So you use some commonly understandable language, correct? Yes. So you talk to that person. If it is like Hyderabad restaurant, you prefer maybe Telugu, English, Hindi, right? Fine then. So why are you using that language? Because you want to place an order and server should be able to understand that language, right? Okay. So that means you are using a language that is commonly understood by both of you, correct? Perfect. So here you are using a common language, right? To place your order. So to place a request in the database environment, to place a request to the server, you need to use a commonly understandable language, which is SQL. You need to talk to the person or talk to the server in SQL language here, right? Then server understands it. Then what is the job of the server? In restaurant, go to the kitchen first to explain what the customer, has ordered, right? Perfect. Then, so then the server goes to the kitchen, right? And kitchen, here you can consider your kitchen as your database, a physical database. In kitchen, what is that you see? You see all those ingredients that are used to prepare the food, right? So all those, what is that, rice or whatever it is, right? So you can consider all those things are like your tables, views, right? So many other things also there in the database. But yeah, we focus more on tables and views. Should be fine. Right. So what is it? Do we, what is this, the person who is preparing the food does is mixes all those different things, right? Based on the instructions given by the server. Correct. Perfect. Now, while doing that, adds, spices to it and different ingredients to prepare the food, right? So here we use where clauses, grouping, having, joins, unions, right? When we do all that in restaurant, we get the food prepared. In our database, we get the data set prepared, or a result set, we call it, right? Then what is the job of the server again? Pick up the food, come back to our table, serve the food, right? Similarly, in our database server, picks up the result set, comes back to us and delivers the result set, right? In restaurant environment, we call that person who visited the restaurant a customer. Here in database environment, we are the client and we talk to the server using which language? Why SQL only? Why not English or Spanish or German or anything? Because server, yeah, you need to use a language that is a common between both of you. So SQL is a common language. But you get a question here. When I go to a Hyderabad restaurant, I can use Telugu, right? Telugu has accents again, like, you see Telangana accent is different, Rayalaseema accent and Costa Andhra accent is different. But when you use a different accent of Telugu, will the server be able to understand? Yeah, almost, right? So yeah, almost like 90-95%, maybe 99% also they can understand, right? Language is same, but maybe the usage and the accent may be little different, right? So here about SQL also, while talking to the server, there are different variants available. Depends on the type of the server you talk to. If you are talking to a SQL server from Microsoft, you need to use a variant TSQL, Transact SQL, and that is what we are going to learn here. There are other servers also, right? Oracle, you use Oracle SQL, you have MySQL, right? So different variants of SQLs also available. But in our class, we use Microsoft SQL Server as our server application. So it understands TSQL, Transact SQL, right? So it depends on the server that you are talking to. You need to change this language also. There are no major differences, between these languages. They look very much similar. 95% of the commands, they look very much similar. Even though you learn one variant of SQL, you will be able to write the queries in other variant very easily. It hardly takes any 2 minutes to understand that concept, okay? Because the core functionality of all these functions or the concepts, they remain same. Just that the terminology may be different. A simple example would be if I want to restrict the data extraction, I don't want to get millions of records. In TSQL, I use a command top 10 records. You get me only top 10 records. Though the table has 1 million records, for sampling purpose, I want to just see top 10 records. What is that I write? Top. The same thing in MySQL, if you want to write, we use a command limit 10. You see, top 10, limit 10. So you easily understand that, okay, top restricted to only top 10 records, it limits it to only top 10 records. So both of them are kind of same, but the terminology is different, right? So this will, anyways, it will come slowly to you, but you understood, right? So kitchen is a database for us where we have all the ingredients. They are our tables, stored procedures, functions, triggers, indexes, all that stuff stored, right? Yeah. So simple thing. That's what I already explained. Like taking the orders is basically running the queries. So server comes to you, right? And you place an order and it goes back and does the required thing and delivers, right? Here we get the result set. In restaurant, we get food, right? After processing it, right? That process may involve different steps like writing the clauses, different groupings or unions, joins, aggregations, whatnot. It depends on the requirement, right? So the menu basically you see select, insert, update, delete, and these are the data manipulation commands, DML. Yeah. So basically, whatever you see in restaurant, if you can relate it with the database, it's very much similar. We are customers there in a restaurant. We call ourselves here as a client, and client talks to the server. Server understands the requirement because we use a commonly understandable language, which is SQL. The server job is to go to the database and get the, all the required stuff prepared, and our result set will be delivered to us, right? So which server are we working with? Microsoft SQL Server. Which language we are going to use? TSQL, Transact SQL. The client application, because if you want to talk to the server, there needs to be a client application wherein you pass your queries, right? The client application here is SSMS, SQL Server Management Studio. So that is a client application. So let's say if you are working with MySQL Server, then the client application is MySQL Workbench. If you are using Oracle, there is Todd. There is a client application. Different clients are there. You can use Power BI also as a client application. You just need to write a SQL query inside Power BI. See, anything that tries to extract the data, you can say client here, right? I'm talking only extraction of the data, but the clients can do other things also. It can manage the data, it can update, insert, delete the data, it can create new databases, but let's not get into that because our job is to do the data extraction and create the reports out of it. So let's talk only from the data extraction standpoint, okay? So anything that helps us to extract the data, you can consider that as a client, but here we use a dedicated client, which is SSMS, SQL Server Management Studio. Done? Perfect. So you got some idea, right?
Sure.
Yes, please.
Hello. Can you go back to the fifth slide?
Yeah.
Can you explain this slide once again?
Okay, so we are a client, right? What is it we do? We place an order, right?
Yes.
So nothing but we send a query. Let me write that also. Anyways, we'll be doing step by step. So I told you, right? I'm a client. What is my client application? SSMS, SQL Server Management Studio. I'll just connect. And I'll take one simple query here. There are so many databases, but I'll just show you a very small table here. So I'm talking to my server now, saying, okay, I want to get all the records that are present in the employee table. So this is my requirement, right? Client sends a query. Now I can trigger this query, execute that. So when I do that, the server writes it down, right? So that needs nothing but the query gets passed, right? So it needs to understand that query and it needs to make my database also understand, right? And then once I send it, my server understands it, right? My server will go to the physical database, looks at this particular table, and as per my requirement, get me all the columns when you write a star. I'll take you through, okay? I'm not explaining the query set. I'm just only showing you how the environment looks, okay? But I'm just triggering this query. Server understood it, right? Went back to that database and looks at the table employee because I requested for all the columns. So it has extracted all the columns, right? Data got processed and result is written. So here's my result. And it took what? 0 seconds. It didn't even take 1 second to process that query. But sometimes the queries will take more time. I'll tell you why. You are placing an order, right? Hyderabad, right? Friday, let's place a biryani order, okay? But you gave very specific instructions. Biryani is a standard one, but you told, no, I don't want the standard biryani. I want my specifications are there for this biryani. So you need to add very little spice, right? More salt in it. I'm just giving, okay? Yeah. And I don't want more masala, right? The food to be cooked for 15 minutes. You are giving the time frame also, right? Of course, Hyderabadi biryani cannot be customized that much, but I'm just giving you an example, okay? But yeah, when you are placing an order with with so many instructions, tell me something, if it is not a standard order, right? And it has got so many instructions and specifications, okay? Will it take more time to process the food? Yes. Similarly, if you place a very complex query, like I want this, but not this, right? And also include this and join the other table and union the some other table and get me that output group by so and so. When you give this, definitely the server will take more time to process the request. You got the point, right? It all depends on the kind of query you send. If it is like a very simple query, get me 1 plate biryani, done, you see it, right? They say that like in 5 minutes they will deliver it. But when you say like, I want what? Any vegetarians are there? Sorry for you, but yeah, that's I want tandoori chicken. Right? They simply say that, okay, it's going to take 25 minutes and you will have to wait. It depends on the kind of order you place. Server will let you know, like, this is the time it is going to take. The same way, when you pass a specific query with so much complexity in it, it will take more time. And it also depends on how much data you are expecting, right? See, one person, 1 plate of something, it hardly takes like 20-25 minutes. But if you say like, okay, I got like 100 people and you want, you need to serve the food for all 100, definitely it will take more time. So nothing bad. If the result set is too big, whatever the result that you're expecting is too big, it will take more time. Got the point? Is that fine?
Yes.
Done. Same. Correct. Yeah. More instructions, more conditions, right? Definitely takes more time. Now you understood this, right? What is SQL? It's a language. What is a server? Server that manages the database, right? And why do we need to talk to the server in SQL language only? Because it's a common language. Yeah, I think now you can easily understand this image. Where are we in this entire environment? Where are we? We are here, right? We are using a client application, something like SSMS, right? And we send a query. It could be any type of query, depending on the roles and responsibilities that we have. It could be a data storage query, data retrieval query, administration reports queries, or data security. So let us talk about only a data retrieval query. So we use our client application. We send a data retrieval query and it hits the database server. goes to the physical database, and I write, get me or select star from transactions where the transaction date between, 1st January 2025 to 31st January 2025. So only that part of the data will be processed and will be returned onto my screen as a result set. You got the point, right? So you can pass different types of queries using SQL, but our focus is mainly on this data retrieval activity only. Now you got the point, right? So which server are we using? Which server? Microsoft SQL Server. What is our client application? SSMS. Which variant of SQL will type here in the client? TSQL. TSQL, MySQL, you see very much similar commands. Even in MySQL also, it's just copy paste, it will do the same, right? You understood, right? This is an entire image. Now you get the point? Yes. So we use different, types of queries inside the client application, and the database server, it processes that request and gets us the data. And once we get the data, it's up to us how we want to present it. You may want to create a report using Excel, using Power BI, using Tableau, or using ClickSense, or using Google Data Studio. It's up to you. Understood? Perfect. Okay, so if anyone wants to create a database application, RDBMS, right? Then that person needs to follow these 13 rules proposed by IFCOD, but this is more for the database application developers. This is not for us, right? But one thing is that, in the RDBMS, the data is stored in the form of tables that have the relationships, and these relationships are created using the keys. We'll talk about keys, okay? What is a primary key, foreign key, unique key, and other column constraints also, like, default constraint, not null constraint, right? So many other constraints also there, okay? Advantages of SQL, why, we need to go with SQL only. So as you know that the data is stored in the form of tables there, right? Instead of scrolling through the physical file system, let's say if I want to get one file, what is it I need to do? I need to scroll up, down, and find out a particular, employee data is stored in the form of Word files. Let's assume employee data is stored in the form of Word files in a folder. And I'll ask you, okay, get me the details of Jones. Then what is it you need to do? You need to go to that folder where, all the employees are there and find out, let's say, Jones file is there. You need to go there and open that. Then you will see Jones, what is the employee ID, when did Jones join and all. But if I want to do the same thing in a SQL database table, where ename, right, is Jones. I just trigger a query, I'll get all the data. So instead of physically, scrolling through all those files and find out, the details, so you can directly write a query because it is stored in the form of table, right? So all the details, they belong to Jones or any employee for that matter. I can easily fetch it with the simple queries like this, right? So controlling redundancy and inconsistency. This is another very, very important thing, controlling redundancy and inconsistency. So what is this one? Controlling redundancy and inconsistency. For that, I need to show you a file. Okay. You take a look at this data, right? You see this manager. So all these things are managers only, right? Right?
Yes.
The same values are repeated for multiple number of times, right? So I can say the data is redundant. Multiple times the same values are repeated, right? Developer. But instead of that, what we usually do is that we simply assign a key there. What is one? We look up this one inside this table, and what is one? One is manager. To reduce the redundancy, right? we use this technique. We'll talk about what is this technique. Okay, why do we need to split the data into multiple tables, right? Then what is a dimension table? What is a fact table? How these tables can be joined back when we want to create a report, right? All these things. But for now, just understand that what is data redundancy in a column. If you see the same values being repeated for multiple number of times, you can say the data is redundant. Instead of repeating the same value, what is that we can do? We can simply assign a key to it, and the key can be looked up in some other table to fetch the corresponding values from some other table, right? So someone who completed Excel, you know that how to fetch that formula. VLOOKUP or index match or XLOOKUP, right? Lookup formulas is the one we use, correct? Right. So to reduce the redundancy and inconsistency issues, inconsistency issue is like if let's say department 20 is there, right? So department 20 currently accounts. In future, if we want to change it to accounts and finance, okay? So in this kind of a data, when I want to input a new employee record here, okay? So 7935 and Williams is the name, manager, and this person is now part of accounts and finance, okay? And the rest of the details, I'll just simply drag them down, right? So you see the problem here with this kind of a data, all the previous records are still showing accounts, but the new employee record is showing accounts and finance. Actually, we decided to change the name of the department. So that's the reason we started up giving a name accounts and finance, but the historical data is still showing accounts. So it will create, some inconsistencies in the data, right? But what if I maintain the data like this? If I change here as accounts and finance, yeah, that's it, right? If I change it here, when I try to fetch using a VLOOKUP, using this department ID, use this second column and 0. Yeah, here you will be finding it as account and finance only. Accounts and finance. You understood, right? So this is the advantage of splitting the tables into multiple tables. This is called data normalization process. We'll talk about that. But for now, understand that we don't repeat the same values again and again, because we want to reduce the redundancy in the data and inconsistency issues in the data. We want to reduce them. So that's the reason we do the data normalization. Once you do the data normalization, obviously efficient memory management, okay? So tell me something. If I give you a pen and paper, I ask you to write manager, okay? That is your first word. And I ask you to write number one, just a digit 1. Which one consumes more ink? Manager consumes more ink, right? So similarly, text contents and all, if you write lengthy text and all, obviously you will have to allocate a good amount of space also to store that. But instead of storing manager for multiple number of times, if you just put 1 there, obviously it occupies lesser space, and moreover, it also enables us to create a primary key foreign key relationship between the tables, right? And these keys can be easily indexed for the faster data retrieval. So we'll also talk about that, right? So understand the moment, the benefit or the advantage of doing a data normalization is this. When you split the tables and you reduce the redundancy by assigning the keys occupy lesser space. And keys can be easily indexed. What is an index? I'll talk about that shortly, right? Concurrency control and transaction management, right? I'll once again talk about these things. Maybe let me just give you this example also, indexing. You have a textbook. Let's talk about a financial management textbook, okay? One of those topics is there, mergers and acquisitions in the financial management textbook. And I want you to go to that page, mergers and acquisitions topic. But let me tell you the scenario here. This financial management textbook doesn't have any page numbers, no page numbers. And it doesn't have an index page also. But I ask you to go to the mergers and acquisitions topic, right? And this textbook has about 1,000 pages, right? Then how much time would it take? You need to go page by page, right? If you are lucky, it may be there on the very, very first page. Or it may be there on the very last page also. You're getting the point? It will take so much time. But let me change the same example to a different, in a different way. Now you see this. You have a financial management textbook. You have an index page. Index page, you know that, right? And there you have all the topics and in which on which page these topics are available. And good thing is that each and every page has a number. And now you find mergers and acquisitions is there on page number 510. Then how do you go to that topic? You turn over each and every page to reach there. How do you open that? Directly open, right? But how do you know that? How can you directly go to that page?
I mean, we saw the index first.
Mm.
After that, we got to know this page has this data.
Correct. In the page number 510 is there. Right. And there you have the mergers and acquisitions topic. How do you open that? You go page by page by turning over. How do you open that? Nearest, right? You look at the thickness of the book, and I said it is 1000 pages, and you try to find out the midpoint because it is somewhere around 510. And when you try to open that midpoint, you may land on 490 or 530 or 515 or something like that. You know what you did to open that page? You made your textbook into clusters, 2 clusters. Tried finding out the midpoint. Why did you do this? Because your requirement is there on the 510th page you want to directly go there. To speed up the activity, this is what you did. Of course, you can go page by page and also you can reach there. But to speed up, what did you do? You performed a clustered indexing there. Right? So what is an index? Index helps us to do the data retrieval quickly. Now you get the point why we perform the index. Same, remember indexing textbook with an index page and page numbers, it will give you the clarity. And whatever the way you open, it is called clustered index. So these non-clustered index are there, unique indexes are there, let's not get into that because the database developer who develops the table, that's their responsibility to index the columns to speed up the data retrieval. But we can suggest indexing can be done on certain columns basis on our requirement also. As a data analyst, you can say that, okay, so it would be recommended if you can index this column because we are going to apply so many filters on this column. And if you can index this column, the data, the querying will be faster. You can suggest, but we don't create. Understood, right? What is an index? Right. Concurrency control and transaction management. Right. This is also an interesting thing. I'll give you an example of a GPay transaction. So you would have faced this when you attempted doing a GPay to your friend, to anyone. Money gets debited, but it's a failed transaction, and that money doesn't reflect in your friend's account. What is that you do? You right away give a call to customer care, right? Yes, no? Yes? Yes, no? Tell me this. Let's talk about real-time things. Tell me, do you give a call right away to GPay customer care saying something like, money got debited from my account, but it's not reflecting in my friend's account? You give a call? How many times you actually made a call? How many times the transaction failed and how many times you gave a call? I mean, I never made a call. Yeah, I never made a call. But what gives you that confidence? Like, your money got debited from your account, but not reflecting on your friend's account, right? It's a serious issue. But what gave you that confidence not to call? And anyways, it gets reversed into your account for sure. What gives you that confidence? So that means within that 24 hours, someone will be sitting there and looking at, which one is a successful transaction, which one is unsuccessful transaction. And if it is like an unsuccessful transaction, so let me pass an entry to reverse the transaction. Someone would be working on that. No. So, a good thousands of transactions are getting failed. Let's assume because of XYZ reasons. How many people can you deploy to handle only the unsuccessful transactions? You get the point? Transaction management is other thing that takes care of these kind of issues, okay? So in transaction management and concurrency control, this is what happens. concurrency control, you know what it does? It checks a transaction, either entire transaction is successfully completed or nothing is completed. Right? Successfully completed means money got debited from your account and got credited in your friend's account. It's a successful transaction. Okay, transaction closed, committed. But just in case, because of network issues or banking server issues or something went wrong and money got debited from your account, but it is not reflecting in your friend's account, then the transaction will be rolled back. So you no need to specially do anything there, and everything is automated process. But again, this is part of the application developers. They take care of the process. It's not our job. But in few instances, the transaction management affects our data querying. I'll talk about that in the transaction management sessions. Okay. Fine then. So now you understood, right? What is the concurrency control? The best example is a GPay. Even though you don't give them a call, it will be automatically reversed back into your account. Is because there is a transaction management system in place, and that takes care of either everything is done or nothing is done. Okay. Access control and ease in accessing the data. The whole idea behind implementing a database is to have better access control and who should access what. Different kind of levels we can create. A manager should be able to access A, B, C tables, but analysts should be able to access only A table. So we can create different user profiles, and we can assign basis on their profiles. They can access different sets of data. Part of the data control language, DCL, this is where we grant and revoke the permissions on these database objects. Integrity constraints. This is also interesting thing. So tell me this, if a simple example I'll tell you. Can I use a department ID 60 here? No way. Why no way? Because there is no department ID 60 here in the departments table. So if that ID is not there, you cannot use that here for any of the employees. Data integrity, right? Something is not there in the dimension table that cannot be used in your fact tables. We'll talk more about this fact table, dimension table later, but understand that data integrity. And to maintain the data integrity, we also follow triggers in SQL. A simple example, if an employee is joining in a company, that record will be added to the employee table because employee is joining, right? But the same employee data should reflect in attendance tables, should reflect in payroll tables, should reflect in insurance tables, should reflect in PF related tables. So all these things will be automatically triggered, right? So this record will be available in other tables also automatically, right? Data integrity. So one thing, if it is not there in the dimension tables, you cannot use it. The other thing is, if an employee is is joining a company, that employee record should be present in other few places, it will be automatically triggered. So it maintains the data integrity. So no way that one record is present in one place, in the other place it is not present. No, it's not like that. It maintains that integrity. Multiple user interface. Yeah, let's say your data is stored in Excel file, right? One of the users opened that Excel file and working with it. Other person also can open and work. Yes, can open in read-only mode and work, but we cannot do the modifications, right? So here in multiple user interface, if it is a database, I can interact with the same table, you can interact with the same table, you can insert your own records, I can insert my own records, I can update, you can update, you delete, I delete, everything can be done simultaneously. Right? It's a multiple user interface. The best example is our, billing systems. So multiple operators may be working at the same time, and all the data goes to the same database only, right? And the management of these transactions and all managed by the SQL server or any kind of a server they use. Data scalability, expandability, and flexibility. If you have a database with 1 GB capacity, you can easily increase it depending on the requirement. It's like very easy, okay? Just you go to the database properties and modify that. Security, and we can, as I told you in the data controlling, DCL, you can set up certain profiles and people will be getting different types of access to see different types of data sets or tables, right? It's very easy, but in Excel kind of an environment, it's not that easy to set up the security and all, right? If you give a file to one user, that person will be able to see everything there. But if you grant permission to certain tables in a database, the users can access the data only from those tables. They cannot see anything additional, okay, extra. Right. Before getting into installing the servers, we need to show you a few things. Let's talk about OLTP, OLAP. Then we'll go to the server installation. Yeah, right. So I think by now you understood we are going to work with SQL Server, which is from Microsoft SQL Server. And the language we are using is, which one is it? Which variant of SQL? TSQL, right. And what is the client application that we are using? SSMS. Perfect. SSMS is the one we are using. Right. So coming to the real-time systems, there are two types of systems we see. What are they? OLTP and OLAP. OLTP and OLAP. Online transaction processing, online analytical processing. Two systems. Let's talk about online transaction processing. The best example of online transaction processing is if you go to a shopping mall, you see the billing counters there. They are connected to OLTPs only. Their job is to manage the transactions. So that's why it clearly says it's an online transaction system and manages the database modifications. It manages the transactions. While managing the transactions, what all kind of things they happen there in the billing counter? Just think about only the billing counter. What all things happen there? Let's say you pick up a few products, you go to the billing counter, they scan, right? And they say that, okay, this is the bill amount and you pay it and they generate a bill. So what's happening is that there is a transaction getting recorded into the system. It's an insert statement. So the focus of this system is insert, update, delete. So if you go there, hand over the products and scans it and generates the bill and you make the payment, generates the bill. That means one transaction got entered into it, and on the bill, you get one unique identification number of that bill, be it invoice number, transaction ID, some number, bill number, something they mentioned there, right? So that is a unique identification number for that transaction. So there is a transaction inserted into the table, right? While this transaction is happening, you find your mobile number is incorrectly, it was updated incorrectly earlier. Then that person asked like, is this your mobile number? And you say that, no, my mobile number is so and so. Then what this person does, the billing executive updates that mobile number, right? Depends on the privileges that person has. If that person has an update, access, then that person can update it, right? Then, yeah, you tell that, this is my correct mobile number, and that person updates it. So that is an update state. Then you find two addresses there. One is your home address, one is your office address. And you tell the billing, executive saying, I've quit that company and I've joined a new company. So remove my office address, but keep only my home address. Nothing but delete. So insert, update, delete is the one that you see in that billing counter. So that is managed by the OLTP, online transaction processing. Right? You are getting that? And these things are the original source of data. Why? Because this is where for the first time the transactions are being entered into the system, right? In this example, this is original source. And this original source, why we are using this original source is because the same data can be cloned or can be copied into other databases also later. We'll talk about that process also, right? This is the original source. This is where for the first time the transactions get recorded. Right? Now you got the point. What is OLTP? This is to manage all these transactions. Insert, update, delete are the ones we perform. And this is where the very first time the transactions are getting recorded. Later they can be modified. Later that data can be pushed into some other database. Okay. So let me switch to ATM example. So ATM, is it OLTP? Is it doing that insert, update, delete kind of statements? ATM. And by the way, what is the full form of ATM?
Automated table.
Automated automation, right? Okay. If you ask Apollo guy, they say that anytime medicine. They also have ATM, right? Okay, fine then. So let's say you go to ATM. Yeah. You deposit some money. What is that? Cash, CEDM, right? Cash deposit machines, okay? So certain machines, they accept cash deposits also. Let's say you deposit money, okay? What kind of transaction is it? Is it an insert, update, delete? Insert. So that means you are inserting a new record saying that you have, deposited so and so money. Now your balance is this. Okay, sounds fine. You withdraw the money from ATM, okay? And earlier it was 50,000. Now you will withdraw 5,000. So it's going to be 45,000 is the updated balance. Now you tell me which type of transaction is it? Online participants, which type of transaction is it?
Update.
Update transaction, okay. Others, let me hear it from you. Very, very important. Update, fine then. So today you open your account, 50,000 is showing. Tomorrow it is showing directly 45,000, right? Your balance got updated, but it doesn't leave any track where that 5,000 is gone, okay? Is it okay?
No.
Withdrawing the money is also an insert statement only.
Original.
It's an insert statement. It is not an update statement. Your balance cannot be directly updated. Okay, today it is showing 50,000 and tomorrow it shows only 20,000. You want to know where that 30,000 went, right? Yes or no? Whether you would have withdrawn it or you would have transferred to someone else, there has to be a track to it, right? Right. So that means that is also an insert statement only. Every transaction that you do in a bank is an insert statement, right? Okay. That is where the very first time you recorded the transaction, be it ATM or billing counters, okay? These transactions are short. Yes or no? So how much time do they usually take? It depends, 1-2 minutes, If no one is there, 1-2 minutes, your transactions will be over. The processing time also very, very less. Yes, if you go to a billing counter, no one is there. You only a couple of products, okay? How much time will it take? 2 minutes, 1 minute, maybe, depends. But what if they take half an hour? Is it okay? No, right? So usually these transactions are fast is because we are using very simpler queries. What is it we are doing? We're simply inserting or updating or deleting, job done. You got the point? So what is normalization integrity? I'll come to these points later. But you understood, right? So the OLTP system job is to basically manage the database modifications. And in this process, we insert, update, delete them. And this is where for the first time the data gets recorded and later it can be moved to or copied to some other place. These are usually short transactions because we write simpler queries or we send simpler queries to get them executed and they run really fast. Done. OLTP. So this is to handle all the real-time transactions, right? Then what is OLAP? Online Analytical Processing. This is for the data retrieval and data analysis system, okay? the focus of this system is extract data for analyzing that helps in decision making. What is it we do? We extract the data. Why do we extract the data? Because we want to create the reports and understand what's happening and draw the insights, and so that it helps us in taking better decisions, right? So it is for the decision making. And you see this is not the original source of data, okay? So the data that gets into the OLAP that comes from the different OLTP databases. So different OLTP databases become the source for OLAP. So OLAP doesn't hold any original source of data, okay? So all the data that gets recorded in the OLTP that will be copied or transferred into OLAP. There are dedicated teams for this. Data engineering, you would have heard this. A team named data engineering, and they build the data pipelines. And there are ETL developers. Extract, transform, load. You know what these people do? They get all the OLTP data from different sources and they consolidate everything into one single data warehouse. So this process is called extract, transform, load. They extract the data from different OLTPs, they transform the data into the required shape, and then load the data into a data warehouse, and which is managed by our OLAP system. Okay, so why do we need to do that? Why don't we leave the data inside OLTP and directly connect it to the OLTP and start creating the reports using OLTP? Because that is where the original source of data is recorded, right? But understand one thing, it is always recommended to have two systems. I'll tell you why. Let's do a simple exercise to understand why we need two systems. What is the job of OLTP? To insert, update, delete. Correct? That. And what is the job of OLAP? So whatever the data is there, analyze it and understand what's happening. Yes? Right.
Yes.
Let us, do one small exercise now. Let us play a role of OLTP now. What is the OLTP job? Insert, update, delete. And I'll be giving you the numbers, right? Try to remember them. 10, 20, 35, 45, 65. I'm repeating this. 10, 20, 35, 45, 65. Done. Now you recorded them. Done. You're just doing a job of OLTP, right? Now the third number, what did I say?
35.
35. Make it 40, please. Now you remember the updated list. What did we do when I said make it 40? 35 to 40 is an update statement, right? Delete the second number, please. Which one is it?
20.
20. So you're performing this OLTP activity, insert, update, delete. Now you're with 10. 20 is no more there.
40, 45, 65.
40, 45, 65. Done. Perfect. So doing these things, okay, right? Now you tell me the first and last number sum.
75.
Second,
95.
second number, third number average. And also do a division between the first number and the last number. Whatever just now I'm asking, do the sum, get me the maximum, do the division, pick up the average, and all these things are the decision making things, okay? I want to find out the average sales in the last 10 days. Right? So this will take some time, right? Because it needs to execute certain aggregate functions on the data, right? If I'm assigning both the tasks, like one thing, one side you need to do the insert, update, delete statements. The other side, you also need to come up with the data analysis related answers. You will find it like little challenging there. Similarly, the OLTP system is already engaged in doing a lot of real-time transactions. Back-to-back transactions may be coming. On top of that, if you put one data analysis request also, it may be able to do it. It can get you that output also. But you may be keeping load on that server, right? So what happens is that your end customers who are actually placing those transactions will be suffering or will be, finding latency issues there. You're getting the point? Right? You are already engaged in doing some work, and on top of that, I'll give you one work and do it. Then what happens? The average time will take more time. But when you have dedicated systems, let's say you are handling only OLTP activities, you are handling only OLAP. So this person records only, does that insert, update, delete statements, and whatever the data is there, that gets to you in the form of, with the help of ETL activity. And once the data is there, and you will be handling only that analysis related work. It's now easy, right? Two different systems and managing the things is easy. So the same reason we transfer all this OLTP data into OLAP. That's our data warehouse. It's a central repository of the data that comes from different OLTP databases, right? And moreover, the advantage is if your data is located in multiple OLTPs, and if you want to see the consolidated number, what happened yesterday from all the different locations, let's say Reliance Fresh is there. You have data centers available in Hyderabad, Chennai, Bangalore, Kolkata, and different places, different OLTP databases are there. And a CEO who sits in Mumbai location wants to know what happened yesterday, what is the total sale value, then you need to interact with multiple OLTPs. But instead of that, if you can gather all that OLTP data into one OLAP, like your data warehouse, and then, you can connect to the data warehouse, create a report that shows the entire picture, what happened yesterday. Understood? Right. OLAP has long transactions. Obviously, because it is just not like an insert, update, delete. You query the data. You want to write so many aggregations on the data. You do the joins, you do the unions, you do so many other things. Obviously, they take more time because they are complex queries. Good one, Ravi. Does OLAP system show the live data which is available in OLTP? No. I'll tell you why. If the live data to be present in OLAP, that means the data ETL activity should also happen on live basis. Usually that is not the case. ETLs, they happen, depends on the business requirement. They schedule every hour or every night, right? Usually in the midnight they set up. Once the day's transactions are over, all the data will be loaded into OLAP. Right? That's the reason as a reporting analyst, you usually hear this, okay? Did we get any email confirmation from the data warehousing team that the data has been successfully loaded? Why we wait for that email is because if you want to run your reports, you want to have the updated data in the data warehouse, right? If the data warehouse is not updated with the latest data, even if you refresh your report, you end up seeing the historical data only, not the updated data. So there will be some gap between the OLTP and OLAP, okay? Because OLTP data is your live data. OLAP data, that will have little lag there, right? Depends on the business requirements. Certain processes where I work, there is a 1 week lag. Nothing but all the transactions that are done in the entire last week, they will be they will be loaded into the data warehouse on the next Monday. Business is okay with that. That is how they wanted to drive their business. But certain businesses, I'll tell you one more thing. I worked with contact center analytics. Contact center analytics is something like Deloitte internal call center it is, okay? So we need to analyze the data, like the call flows, how many calls are coming, how the average handling time is there. So many metrics are there for that. So certain things you can do a historical reporting, like, what happened yesterday, how many calls we received, right? What is the average time? What is the longest wait time, right? What is the hold time? What is wrap up time? So many different times and all we can calculate. That is okay, but they also want to do the real time, analytics. Nothing but whatever is there in the OLTP, you want to see it directly, like how many calls are there in the queue, right? So that information is there in the OLTP, not in our OLAP. Because OLAP data, what usually happens is that during the midnight, the data gets transferred into a different system, and from there we can create all the historical reports. That's great. But how many customers are waiting in the queue? That is our real-time analytics. That's what we need to produce, right? Then it is not possible for us to connect always to OLAP. Sometimes we need to connect to OLTP also. You're getting the point? So you usually find some lag between OLTP transactions and OLAP transactions because the ETL needs to take place in between. You understand? A few processes, it's okay to report historical data. Few processes, you need to report live data. That's when we connect to the OLTPs also. Understood? Right. So far, all these points, are we clear? Up to this? So if an oil AB transaction takes more time, is it okay to wait? Okay to wait? And no other way, we'll have to wait because we send complex queries for the decision making, right? So you request more data there. Let's say I want to see last 6 months data. Obviously, it will take some time to extract that. Right. Now, let me quickly talk about what is data normalization process. I already showed you in one of those examples where the data is located in multiple tables. Let me talk about this now. What is data normalization? Okay. Most of you are coming from Excel background, right? Let me ask you a simple question here from Excel. I want to find out what is the total salary paid by the job. Total salary paid by the job. Is it possible to come up with that those insights using this data? Yes? How? Pivot table we can do. Correct. We have salary in the same table, job in the same table. Excellent. Both of them are there in the same table, so we can do that. Okay, I have one more question. So I want to see the average salary paid by the department name. Can we get that? Average salary paid by the department name. Can we get that? Yes, possible.
Yes, department name is also available.
Exactly. Department name is there, salary is there, and we just do the average and we'll get that. Okay, so looks like each and every data point is available in one table itself. Perfect. Let's take a look at this. I want to find out the total salary paid by the job. Nothing but managers, what is the total salary we paid? Developers, what is the total salary we paid, right? Now take a look at this. Only the selected table. Can I get that? What is the total salary paid to the managers, developers? Can I get that using the selected table?
No, because manager is not available.
Okay. So in this table, it's not
We
available.
need to connect to the other tables to get that data.
Correct, yeah. So if you look at this, you need to look up this value here to find out the salaries of different designations. Right? Someone who's good with Excel, you know that answer already. You need to do the lookup formulas, VLOOKUP, XLOOKUP, index match to fetch what is one. Right? Perfect. So can I find out each department wise what is the average salary? I think we need to do the same thing again. So each department wise, we don't have the department name there. What is it you need to do again? You need to look up that value inside this. Okay. Similarly, by the gender, you want to find out how the total salary is paid. Okay. Then do the same thing. In the gender table, you need to see that, right? Right. Now tell me, the previous example is easy or this example is easy to get these metrics? The total salary paid by the department or the average salary paid by the department are different things I asked you, right? Which data set you find it easy? The previous one or the current one?
Previous one.
The previous one, right? Perfect. So the previous one is a denormalized data. What is denormalized data? Each and every data point is available in one table itself. But in the normalized data, the data is available in multiple tables, but they can be joined using these keys. In Excel, you use lookup formulas, right? In SQL, we use joins. Okay, we use the joins, and here we need to understand a primary key, foreign key. What is a primary key? What is a foreign key? We'll talk about that. right? But if the data is available like this in multiple tables, they can be joined together. Yes, it is a normalized data set. Now I have a question. As a data analyst, which one would you enjoy the most working with? Is it a denormalized data you enjoy the most, working with, or normalized data
Normalized.
Normalized.
as a data analyst?
Normalized.
Denormalized? Okay, a few of you are saying denormalized.
Normalized.
Normalized. Okay, may I know why normalized? Why would you enjoy the most working with normalized data? Why? If you ask me the same question, I would go with denormalized data. You know why? Simple. If everything is there in one place, I'm like a data analyst, I'm happy, right? I don't need to write so many formulas to get the data from different places. Yes or no? It's available. Everything is there in one place. I can easily report it. I can easily create the pivots. I can do whatever the analysis I want to do because everything is there in one place. But in the real time, you can't expect denormalized data sets. You always get normalized data set only. I told you why the data is normalized. I told you, right? Why the data is normalized instead of maintaining the same values or inserting the same values again and again. Nothing but the data redundancy we spoke about. To avoid the data redundancy or to reduce the data redundancy, we split a big table into multiple small tables, right? Instead of repeating that manager for multiple number of times, what is that? I repeated only one. One consumes less space and can be easily indexed and for a faster data retrieval. That's what we discussed to reduce the redundancy and better indexing, right? Yeah, all our data in the real time is located in multiple tables like this, right? This is the normalized data set, right? So as a result of normalization, what is normalization? A big table is there, right? And we split that big table into multiple small tables. With the help of keys, we can actually again join it back if needed, right? When we perform this normalization process, we get two types of tables. Dim tables, dimension tables, and fact tables. Okay. So what is a dimension table and what is a fact table? A dimension table that holds categorical data, something like this. It's a dim table. Why? Because it has only the department related information. And a designation table is also a dimension table. Gender table is also a dimension table. Right? They hold only the categorical data, some location information, department information, region information, country information, customers information, products information, right? Only that data, categorical data is available inside the dimension tables. When it comes to a fact table, okay, let me call this as a fact table. Then you get a question, how do you know that it's a fact table? Let me give you a very simple thing here. Remember this. In a table, if at least one column is there, allows you to do the sum, sum, addition, okay? If you can do that, and the result makes sense, consider that as fact table. Of course, the technical definition, it says a fact table contains the numerical data that helps us in doing a summarization, but you can do, you can go through that later. But any table that has a column that allows you to do the sum, consider that as a fact table. You should do a sum and the result should make some sense. Done? Okay. Now looking at this table, yes, I consider this as a fact table because one of those columns, salary, I can do the sum. Tell me sum of salary, does it make sense or not? Definitely yes. For a business, sum of salary is very much matters a lot because they need to arrange those funds to pay to the employees, right? So they need to have the budget for this. Right. Now you get it. What is a fact table and dimension table? Dimension tables hold categorical data. Fact tables hold numerical data. And to consider something as a numerical data, at least one column should be there, should allow you to do the sum. Then you can consider that as fact table. Right? Now you understand what is data normalization? So it is a process of splitting the big table into multiple small tables. As a result, we get dimension tables and fact tables. dimension tables hold categorical data useful for the different dimensions. You can see the number, I mean, different things by the country, by the region, by the customer, by the product category. All these things are part of dimension tables. And any numerical data table is there, at least one column supports the sum, then you can consider that as fact table, right? Usually the naming convention in the real time is also like that. If it is a dimension table, the developers, they start with dim underscore or a D underscore or M underscore mapping tables, they call it, right? If it is a fact table, they write fact underscore, F underscore, something like that. Most of the people, they follow these things. Done. You got some idea now, right? What is a dimension table and fact table? So why do we do this? Is because to reduce the data redundancy and inconsistency issues. All the real-time data sets, we see them in the normal forms only. OLTPs are usually normalized. But OLABs are not that much normalized. They are little denormalized also. Why? Because at the time of inserting, updating, deleting is okay, right? It can be normalized. More number of fact tables and dimension tables can be there. But when it comes to OLAP, they are not usually normalized. They are little denormalized. Nothing but multiple tables are there, right? They try to bring the data as close as possible. Why they need to do that? Because OLAP is used for reporting, right? Data analysis, right? If there are 100 tables and 100 tables will have to have the joins, will take more time. So what they do while doing that ETL activity, they try to bring the data a little closer, closer to each other, so that we can create the schema designs like star schema design, snowflake. We'll talk about that in next session, right? So usually OLAPs are not that much normalized, right? Integrity constraints. So the best example is this already we discussed. Can I give 60 as the department ID here? Is it possible? Is it possible to give the department ID like this? 60? No way. Why no way? Because
It is not there in dimension table.
exactly, it is not there in the dimension table, and the same thing cannot be used here in the fact table. Understood? So not possible. So data integrity. So the data integrity definitely is maintained in the OLTP, but you no need to worry about OLAP data integrity. You know why? Because exactly, OLAPs, they get the data from OLTPs, and if they are maintaining the data integrity constant, whatever is the data there in the OLTP that gets flown into the OLAP, then what is the challenge there? You don't need to worry about the data integrity constraints in OLAP. Understood? Now you got some idea why do we need to have two different systems? One is only dedicated for the data analysis. The other one is to insert, update, delete to maintain the real-time or manage the real-time transactions, right? Perfect. Questions? Okay, great then. So we also need to talk about the schema designs, how the databases are designed and how the relationships are created or the joins are created. I'll show you that in the upcoming session. So we'll also have to cover how to install the servers and SSMS, right? I want you to do one thing. Just download this from this location. Just click on that and ask for the material. They will share the material. And if you can come down here, Developer 2022 fully featured edition. This is only for the development and testing purpose, non-production environment. Okay, we cannot deploy this in a production environment, but only for learning purpose, right? We can download this. Just click on that link, scroll down a bit, and you see developer, and just click on this, and SQL Server 2022 developer edition will be downloaded into your downloads folder. Then you need to go to that folder and just do let me just do that. It hardly takes any few seconds to download that, 4.1 MB. And if you go to the downloads and just do a double click, and this would take some time to install, okay? Right? Just do that. Just double click like any other application that we install, right? Those installation instructions are here, the server setup. You click that, you scroll down. As per the screenshot, it shows 2017, but currently 2022 is there. Just go there, download folder, double click, Go with basic installation. Complete up to 6 only, okay? I'll tell you how to enable the TCP/IP protocol and all, why it is needed. I will discuss that later because, and anyways, we are not the server administrators to learn all these things, okay? But we'll have to do it because in our system, a server is there. So we are the server admins. So that's the reason we will learn that skill also. So download it, install it, go with the basic setup. This will take a good half an hour or 20 minutes, depends on the internet speed, right? And once it gets installed, the next one is client installation. So click on this link, okay, slide number 10. If you scroll down, which is currently 20.2, click on this. This is about a 600 MB file. Once it gets downloaded, then go to the downloads folder. Again, just do a double click, next, finish. You don't need to do anything. I'll let you know what we need to do after that to configure our server and the client. And a couple of sample databases. Click this link also. OLTP and data warehouse 2 databases. OLTP 2022, data warehouse 2022. These two only. Just click this and click this, somewhere around a good 700 MB, both the files, right? Just download them. Just click, that's it. It will be downloaded. Just keep them ready. You don't need to do much. I'll let you know how to configure your server and client. Clear? Just download because it takes some time, right? That's the reason. Just download and be ready. That's it, right? So up to this point, everyone is clear about the topics, questions? Online participants, any questions?
We can download it on mobile.
No. You require Windows system, PC. Okay. I don't think these are supported in Apple products. They are designed for Windows. If you have only Apple MacBook or something, my recommendation, have a secondary operating system in Mac, which should be Windows operating system, and there you can install this. Okay. So material package, I think they would have uploaded already. If not, just reach out to them. They will help you out how to download. They will grant access to you. Just go there, download, and just be ready for Monday's session. Done? Questions? Right? Configuration, no need to worry. I'll explain. I'll take you through step by step. Okay. Great then. So thanks everyone for attending today, and let's catch up on Monday. Thank you.
Thank you.
Thank you, sir.
Thank you, Kishore.
Thank you.